This is section 1.2, finding the domain and range of a function. So if you want to take a moment to pause the video and just write all of this down, you can do so. This is really, really important because you will have a couple questions like this on your exam. So make sure that you know these. Some of them are going to be review for you, and some of them may not. So if there's a couple of them that you don't know, that's fine. I'm just going to go ahead and just show you, and I'm going to tell you guys which ones to emphasize. So the first thing is just what I have on the left hand side is just the types of functions. So these are functions that you've already have seen before in the past. So we've looked, you've seen polynomials. Polynomials, a good example of those are like x squares, x to the power of 3, linear equations like 1/4 x minus 1. So those are really easy because the domain, which is going to be now on the right hand side, is all real numbers. And the way that we write all real numbers is from negative infinity to positive infinity. Okay, so this is what we call interval notation. So at this point, hopefully you are very good with interval notation. Okay, so interval notation, remember infinity is never going to be included. You're always going to have a parentheses around the infinities. Okay, because infinity is not a number, it's just an approximation. Okay, so that's going to be, oh, I will interval function, interval notation. Okay, so that's so it doesn't really matter how complicated the polynomial is, as long as you have everything with this with a polynomial, which is basically a positive integer raised to the power of a variable, then that's basically going to be a polynomial, and they're always going to be all real numbers. Rationals, think of rationals as a polynomial divided by another polynomial. Whenever you see like a fraction between two polynomials, that's basically a rational function. Rationals, in order to find the domain, just basically set the denominator equal to 0 and solve for the values of x, and exclude those values from the domain. Okay, so basically remember that you cannot have a 0 on the bottom. So 0 is not, you cannot have that, so you set the denominator equal to 0 and to see what x values are not allowed. Then we have radicals, which is basically the square roots. So you have two different kinds. The first one's even and the other one's odd. So whenever you have even radicals, like a square root or a fourth root or a 10th root, what you're going to do is you're going to set the radicand. The radicand is basically the thing inside of the radical. You're going to set this greater than or equal to 0. Because remember, why greater than or equal to 0? Because a radical can be positive or it can be 0. So, and then you're going to solve it. And then that's basically going to be your answer. Odd radicals, those are basically cubed roots, 7th roots, 5th roots. It's really, really easy. It's just all real numbers. You can plug in any number, a positive or a negative number, and you're always going to have a something in the domain. These trig functions, we won't focus a lot of them in this chapter, but do keep them in the back of your mind, because we will be doing this a little later when we get to trig functions. But remember that sine and cosine, they just have a domain of negative infinity to positive infinity. They can be any value. Tangent and secant, we can't quite write them in interval notation, so we write them in set builder notation. What set builder notation is that all values of x, this line stands for such that x is not equal to pi over 2 plus pi k. Here k is an integer. So you should have seen this in trig. And then you have cotangent and cosecant, which is basically all the vertical asymptotes. So x cannot be all the values of x such that x cannot be pi k. So the trig functions, you don't need to worry about them, because I know a lot of the times in trig, some professors don't teach you how to find the vertical asymptotes, but I'll show you how to find these vertical asymptotes when we get to the trig stuff. So for right now, don't worry so much about the trig, but do put a star next to the polynomials, the rationals, and the radicals, because you will be doing those extensively in this chapter, and then later on as well. So I think the best thing to kind of do when we're doing when we're trying to find the domain is just do a couple of examples to finally get kind of good at that. So let's start off by just saying find the domain. So let's start off with this function. F of x is equal to 3x to the 10th power minus x to the 4th power. So what is going to be the domain in this case? So in this case, you can kind of see that this is a polynomial because you have the powers of the variables are just positive values. So in this case, we have the first case, which is a polynomial. So in this case, it's all real numbers. So the domain is going to be negative infinity to positive infinity, which basically means that I can plug in any x value in here that I want, and I'm always going to have something that's defined. Okay, so part B. So what would this be? So you have the cubed root of x to the 100 power minus x cubed. Well, in this case, we have a radical, and the radical is odd. So when we have odd radicals, we know that immediately the domain is going to be negative infinity to positive infinity. So we didn't have to do anything for this one. Okay, and that's the answer. What about if I had now g of x is equal to this, the 10th root of x over 4 minus 3. So here in this case, the radical is even. So what we're going to do is we're going to take the radicand, which is the thing in the inside, this guy, x over 4 minus 3, and we're going to put this greater than or equal to 0. And we're going to solve for the value of x. So we're going to add the 3 over. So I'm going to have x over 4 is greater than or equal to 3. Then I'm going to solve, let's see how this is division of 4. So I'm going to multiply by 4 to the other side. This cancels out. So x is greater than or equal to 12. Okay, this is the answer, but we want to write it in interval notation. So if I were to draw a number line, and let's say here is 12, 12 here is included. So we draw like a closed circle because we're including, and it's everything that's greater than 12. So it's going to be all of this. Here's everything that's greater than 12. So the way that we write it is we write 12 is included with a bracket all the way to positive infinity. And infinity is never included. Okay. All right, so now let's do this other problem. Let's say we had h of x is equal to the square root of x squared plus 7x plus 12. Okay, now in this case, notice that we have another even radical. So what we're going to do is we're going to take the inside, this x squared plus 7x plus 12, x squared plus 7x plus 12, and we're going to write this greater than or equal to 0. Okay. Now in this case, the way that you deal with these types of problems is like, let's first imagine that we're doing an equal sign. Let's say we have x squared plus 7x plus 12 equals 0. Okay. So now what we're gonna do is let's just pretend that we know how to we're doing this one, and we're gonna come back to the inequality. So let's start off by factoring this guy out. So this is x and this is x, a 4 and a 3, and we're gonna add and add. So this is gonna give me x plus 4 equals 0, and then x plus 3 is equal to 0. So then we're gonna solve for the value of x. So x equals negative 4, and then x equals negative 3. Okay, now one of the things that we have to be very careful with is that we need to think about, we know that these are the values that's is going to give me 0, okay? So we already figured out when it's going to give me 0, but I don't know when it's going to be greater than 0. So one thing that you have to do is you have to check. So if I were to draw a number line, and here is negative 4, and here is negative 3, we know that these guys are included because we know that they're going to be 0 there. So these guys are going to be included. Now, what about in the others, in these intervals? So one thing that you want to do is check the points. So let's pick a number that's less than negative 4. So I'm going to use this guy. I think it's going to be easier to work with this guy. So I have x plus 4 and then x plus 3. So let's pick a number that's less than -4. So I'm going to plug in -5. So I'm going to have -5 plus 4, -5 plus 3. Notice that's going to give me a negative number. This guy is also going to give me a negative number. A negative times a negative gives me a positive. So here I'm going to get positive numbers. Now let's plug a number that's between -4 and -3. So a good alternative would be maybe, I don't know, -3.5. So I'm going to plug in -3.5. So I'm going to have -3.5 plus 4, -3.5 plus 3. So this is going to give me a positive number. This guy is going to give me a negative number. A positive and a negative give me a negative. So here in this interval, you're going to get negative numbers. And then let's pick something that's greater than 3. The easiest number is 0. So x equals 0 right here. So I'm going to plug in 0 plus 4 and then 0 plus 3. So all I'm doing is plugging it in here. So this guy's going to give me a positive number. This is going to give me a positive number, a positive, and a positive give me another positive. So here what we were looking for, remember that when we were looking at the inequality, we were looking at everything that was positive and equal to 0. So we're just going to look at the interval. So in this case, the interval is going to be everything that's, so here you have all the values that are from -infinity all the way to 4. So this is all good. This is not good because we don't want the negatives. And then everything over here, which is going to be to positive infinity. So it goes from -infinity all the way to -4, and -4 is included. We're going to not include anything in the inside, and then we're going to include this -3 all the way to infinity. And the way that we include this, that is this thing and this thing, or this thing, is you're going to write a little u. This u means union, which means that you're including both of these intervals. Okay, so this will be the domain. Okay, so this one was a little bit more involved. Okay, so we're in part D. Let's do another one. So let's say we want to figure out f of x is equal to 3x plus 1 divided by x squared minus 16. Okay, so remember this is a rational, and the way that we deal with rationals is that we want to set the denominator equal to 0. So the denominator, we're going to set it equal to 0. In this case, the denominator is x squared minus 16. At x squared minus 16 equals 0. You're going to add 16 to both sides. So you're going to have x squared is equal to 16. And now you're going to take the square root. So when we do this, you're going to take the square root. And then you're going to add a plus or minus. So you're going to have x is equal to plus or minus 4. So what we're going to do with these numbers is that we're going to exclude them. So basically, it can be any number that we want except these two numbers. So these two numbers are not included. So it's everything but those numbers. Okay, so the way that we're going to write them, imagine negative infinities over here, positive infinities over here. So it goes from negative infinity to -4, and I'm not including it, so a parentheses means not including it. Union, we can include everything in the inside, which is going to be between -4 and 4. That's not included. Union, now it's going to go to 4 all the way to infinity. Not included. Okay. Okay, so let's just do one more. So let's say we wanted to do g of x is equal to 1 over x squared minus x minus 6. Okay, so remember we have a rational again. So what we're going to do is we're going to set the denominator equal to 0. So we have x squared minus x minus 6 equal to 0. Let's factor this thing out. So this is gonna be what, 3 and 2. This is going to give me a positive. This is going to give me, no, wait a minute. This should be a negative. And this one should be positive. Okay. So this is going to be x equals 3 and x equals negative 2. So remember that these cannot, we're going to exclude them. So when we write them in the number line, you have a negative 2. We're excluding that guy, and we're also excluding the 3. So it can be anything that we want except those two numbers. Remember, negative infinity is over here, positive infinity is over here. So it's going to be from negative infinity with a parenthesis all the way to negative 2, not included, union negative 2 all the way to 3, not included, union 3 all the way to infinity, not included. Okay? So one thing to kind of remember is that the pair of parentheses, these just kind of mean not included. So I'm not including that number. And if you have some brackets, you're including the number. Okay? And of course, you can have a pair of brackets and parentheses at the same time. Okay? So that's basically the gist of the domains. Be very careful. I think the one that was a little bit more involved was maybe part D. You can go ahead and review it again. But that's the gist of it with the domains.